2025, the year humanity stopped looking at the stars and started living among them. The year we returned to the moon, not to visit, but to stay. The year Mars revealed secrets buried for billions of years. The year our telescopes peered so deep into the cosmos that we saw galaxies being born when the universe itself was still an infant. Ancient peoples believed the heavens were eternal and unchanging. 2025 proved the opposite. The cosmos is alive, evolving, and stranger than anyone imagined. This is the year everything changed. This is the story of how we learned we're not just on Earth, we're in space, and space is coming to meet us. For thousands of years, humans looked up and wondered. We told stories about the moon, the Greek Selene, the Roman Lunar, the Chinese Chang'e, who drank the elixir of immortality and floated to the lunar surface to live forever. We imagined Mars as a world of gods and warriors, Ares to the Greeks, Mangala to the Hindus, the bringer of war and transformation. But in 2025, these myths became memory. Because this year, the moon and Mars stopped being distant lights in the sky and became places where humans work, explore, and prepare to live. This was the year NASA's Artemis program established a permanent lunar outpost. The year multiple nations landed on Mars, not just with rovers, but with equipment designed to search for living organisms. The year the James Webb Telescope and its successor instruments revealed exoplanets with atmospheric compositions that suggest, not prove, but suggest the presence of biological processes. 2025 was the year we stopped asking, "Are we alone?" and started preparing for the answer. Today, we're reviewing the cosmic headlines that defined 2025, the discoveries that made scientists weep, the missions that succeeded beyond expectation, the mysteries that deepened rather than resolved. Because the universe, as we learned this year, has no interest in giving us easy answers. It wants us to keep looking, keep wondering, keep reaching. Let's explore what we found when we did. On March 15th, 2025, Artemis IV touched down at the lunar South Pole. Unlike Apollo, this wasn't a visit. This was colonization. The landing included habitat modules, a nuclear power system, and drilling equipment designed to access subsurface ice and convert it to breathable oxygen and rocket fuel. By June, Artemis Base Alpha was operational. 4 astronauts, 2 American, 1 European, 1 Japanese, began humanity's first extended stay on another world. Not days, not weeks, months. They're still there as I record this, conducting experiments, testing life support systems, and proving that humans can survive away from Earth. The ancient Chinese myth of Chang'e tells of a goddess who lives on the moon, forever separated from her earthly love. But in 2025, Chang'e 7, China's lunar South Pole mission, landed just 50 kilometers from Artemis Base Alpha. For the first time, multiple nations had humans on the moon simultaneously. Not separated, not isolated, working in their own ways toward the same goal, making the moon home. But the moon revealed more than just its surface this year. In August, ground-penetrating radar from the Lunar Reconnaissance Orbiter confirmed what scientists had suspected: vast networks of lava tubes beneath the surface, some large enough to contain entire cities. These aren't just geological curiosities, they're ready-made radiation shelters, natural habitats requiring minimal construction. The moon, it turns out, has been preparing to host us all along. Then came the water discovery. Not ice at the poles, we knew about that. But in October, sensors detected signatures consistent with liquid brine, super salty water that remains liquid in extreme cold, trapped in shadowed craters at depths accessible by drilling. Liquid water on the moon, not just frozen history, but potentially usable resource. The Apollo astronauts planted flags. The Artemis astronauts are planting futures. Private companies weren't far behind. Blue Origin's Blue Moon lander delivered the first commercial payload, mining equipment designed to extract rare earth elements from lunar regolith. SpaceX's Starship completed its first uncrewed moon cargo mission, delivering 100 tons of supplies. The moon is becoming more than a destination. It's becoming infrastructure. The ancient dream of celestial habitation, once myth, is now logistics. But perhaps the most profound moment came in December when astronauts at Artemis Base Alpha conducted the first off-Earth religious ceremony, a multi-faith service celebrating humanity's expansion into the cosmos. Buddhist prayers, Christian hymns, Islamic calls to prayer, all offered from humanity's newest home under an Earth that rises and sets just as the moon does from our original world. The heavens, once the realm of gods, now host humanity. And we're learning that the boundary between the divine and the achievable was only ever in our minds.
If the moon was about establishment, Mars was about revelation. On February 10th, 2025, NASA's Perseverance rover, after years of collecting samples, deployed its sample cache for future return to Earth. But it also did something more immediate. It transmitted high-resolution images of what appeared to be fossilized microbial mats in ancient riverbed sediments. Not confirmed life, not yet, but structures that, on Earth, would unquestionably be biological. The images sparked immediate scientific debate. Were these Mars' first confirmed fossils, or mineral formations that coincidentally look biological? We still don't know, but the question alone changed everything. Then, in May, the European Space Agency's ExoMars Rosalind Franklin rover finally launched after years of delays. By September, it touched down near Mars' ancient northern ocean shoreline, a region that billions of years ago may have been a sea. The rover's drill, capable of reaching 2 meters deep, began extracting samples from layers of rock that formed when Mars had liquid water on its surface. The samples revealed organic molecules, not life, not even necessarily from life, but complex carbon-based chemistry of the type that, on Earth, precedes biology. Mars once had the ingredients, the conditions, the chemistry. Whether it achieved life remains the greatest open question in science. But the real shock came from orbit in July. Data from the Mars Reconnaissance Orbiter's ice-penetrating radar, SHARAD, revealed something beneath the southern ice cap that scientists are still struggling to explain. A void, a cavity. Empty space, roughly 50 kilometers across, beneath 2 kilometers of ice. Too large and too regular to be a simple ice cave, too geometric to be uncomfortable. Scientists proposed explanations: collapsed impact crater, ancient lava chamber, unusual ice sublimation. But the radar returns show something else: internal structure, patterns within the void. Something the radar can partially penetrate, but not fully resolve. It might be nothing, geology we don't understand, but it might be something, a preserved pocket from when Mars was habitable, a time capsule sealed in ice. We won't know until we go there, drill through, look inside. That mission is being planned for the 2030s. For now, Mars keeps its secrets. Meanwhile, in Hindu mythology, Mangala, the Mars deity, represents hidden knowledge, transformation, and things buried waiting to be discovered. In 2025, Mars lived up to its mythological role. Everything we found only deepened the mystery. China's Tianwen-2 mission achieved something equally remarkable: the first successful sample return from Phobos, Mars's largest moon. The samples, returned to Earth in November, contained material that suggests Phobos isn't a captured asteroid. It's debris from an ancient impact on Mars itself, meaning Phobos is made of Mars. The samples may contain Martian atmosphere, Martian water, Martian chemistry from billions of years ago, preserved in space. We're not just studying Mars from its surface, we're studying it from its moons, from orbit, from every angle. And it's responding with questions rather than answers.
The James Webb Space Telescope transformed astronomy, but in 2025, it had company. In March, the Nancy Grace Roman Space Telescope launched, a mission designed not to look deeper, but wider. While Webb focuses on distant, faint objects in narrow fields, Roman surveys huge portions of sky, mapping dark matter, discovering thousands of exoplanets, and searching for the faint signals of the universe's earliest stars. Together, Webb and Roman became humanity's cosmic eyes, and what they saw defied expectation. In April, Webb detected an exoplanet, designated K2-18F, where the atmospheric spectrum showed something unprecedented: dimethyl sulfide. On Earth, this molecule is produced almost exclusively by biological processes, specifically by phytoplankton. It's a biosignature, not proof of life, There might be non-biological ways to produce it, but a red flag, a maybe, a possibility. K2-18F is 120 light-years away. We'll never visit it. We'll never know with certainty unless we detect additional biosignatures or, impossibly, receive a signal. But for the first time, we have a candidate world where life might exist. Not microbial, not simple, complex enough to affect atmospheric chemistry on a detectable scale. The scientific community remains cautious. Extraordinary claims require extraordinary evidence. But the detection has launched a focused campaign. Dedicate telescope time to K2-18F. Search for confirming signatures. Build a case, one spectrum at a time. Then, in August, Roman discovered something that shouldn't exist. A galaxy from 300 million years after the Big Bang that's far too massive. Early universe galaxies should be small, primitive, still forming. This one is fully developed. The existence challenges our models of how galaxies form. We don't know how something so large could assemble so quickly in the early universe. It's not the first anomaly. Webb has been finding oversized early galaxies for years, but Roman's wide survey showed these aren't rare exceptions. They're common. Our models of cosmic evolution are wrong, or incomplete, or missing some fundamental process we haven't imagined. Science doesn't fear being wrong. It fears being boring. And the universe in 2025 proved it's anything but boring. In September, the European Extremely Large Telescope in Chile achieved first light. With a 39-meter mirror, the largest optical telescope ever built, it immediately began detecting exoplanet atmospheres in unprecedented detail. Within weeks, it confirmed the Webb detection of K2-18F's dimethyl sulfide. Independent confirmation. The signal is real. And in November, the Event Horizon Telescope, the global network that first imaged a black hole, released new images of the black hole at the center of our own Milky Way, Sagittarius A star. The images show something unexpected: asymmetry. The accretion disk around the black hole isn't uniform. It's lopsided, suggesting something massive orbiting close to the event horizon. Possibly another black hole, possibly a stellar remnant, but something we can't yet resolve. The universe is full, crowded with mysteries. The more we look, the more we find. And 2025 was the year we looked harder than ever before.
2025 wasn't just about distant discoveries. It was about close encounters. On June 29th, asteroid 2025 MK passed Earth at just 150,000 kilometers, closer than the Moon. It wasn't large, about 70 meters across, but had it hit, it would have released energy equivalent to 50 Hiroshima bombs. It didn't hit, but we only detected it 3 days before closest approach. The event shocked planetary defense experts. Despite decades of near-Earth object tracking, we're still finding asteroids at the last minute. NASA's DART mission proved we can deflect asteroids, but only if we detect them early enough. 2025 MK was a warning. We're not ready. In response, the United Nations approved funding for the NEO Surveyor satellite designed to detect 90% of potentially hazardous asteroids within a decade. It launches in 2028. Until then, we watch the sky and hope for luck. But space wasn't just threatening, it was collaborative. In 2025, the International Space Station marked 25 years of continuous human habitation, a quarter century where humans have lived in space uninterrupted, longer than many nations have existed. The ISS is more than infrastructure. It's proof that humanity can cooperate off-world even when relations on-world fracture. And in October, the first commercial space station, Axiom Station, launched its core module. By 2030, it will replace the aging ISS. But unlike the ISS, Axiom is privately owned, commercially operated, and open to tourists. Space is transitioning from government to market, from exploration to settlement, from extraordinary to ordinary. Ancient myths spoke of humans ascending to the heavens as punishment or reward, being cast out like Lucifer or ascending like Elijah. But in 2025, we're ascending by choice, building homes, creating economies. The heavens aren't a destination, they're an address.
2025 was the year the future arrived early. We didn't just send missions to other worlds, we started living on them. We didn't just discover distant galaxies, we found ones that challenge our understanding of physics. We didn't just search for life, we found candidates that might host it. But more than discoveries, 2025 was about perspective. For millennia, humans looked at the moon and Mars and saw gods, myths, stories. In 2025, we looked at them and saw real estate. We looked at distant exoplanets and saw neighbors. We looked at the early universe and saw puzzles demanding solutions. The myths aren't dead, they're transforming. The moon is still sacred, but now it's sacred as humanity's first off-world home. Mars is still mysterious, but now we're unraveling its secrets with drills and rovers. The stars are still eternal, but now we see them not as fixed lights, but as dynamic, evolving systems where planets orbit, where life might exist, where futures unfold. 2025 taught us that the boundary between myth and reality is thinner than we thought. The ancient dream of celestial habitation is now engineering. The hope for cosmic companionship is now astrobiological chemistry. The wonder at the universe's vastness is now measured data. But here's what hasn't changed: the wonder itself. Every discovery raises new questions. Every answer reveals deeper mysteries. The universe doesn't diminish with knowledge, it expands. This is Myths of the Cosmos. If you want to continue exploring where ancient dreams meet modern science, where mythology becomes reality, where the cosmos reveals itself one discovery at a time, subscribe to our channel. Because 2026 is coming, and if 2025 taught us anything, it's that the universe is just getting started. The cosmos has stories to tell. We're learning to listen, and what we're hearing changes everything. Until next time, keep looking up. The future is happening above your head.